Okay, so this chapter 8, we're just kind of very briefly touching on a couple concepts that we kind of need to understand as we move on. And some of it we've actually already kind of used, so we learned how to solve equations that had rational expressions. So chapter 8 talks a lot about rational expressions, and we can go into a lot of depth, but we're not. We're just going to mostly learn how to simplify some things. So it's basically like knowing how to apply factoring to something else. So really, a rational expression is just something that looks like a fraction with a lot of variables in it and stuff, like some concepts that have a lot of variables. The first example really is just something we already learned how to do, how to reduce that fraction using our exponent rules. Remember that? So we can, and you can do it in your calculator, at least the number part if you want, because remember this 36/27, that those numbers can reduce by 9, like 9 can go into 36. How many times? 4 times, and 9 can go into 27 3 times. Remember, if you're still kind of feel uneasy about reducing fractions, or if it's a big one and you just don't want to think for at that moment, your calculator can do it for you. So, I mean, I never want you to rely on your calculator, but know when you can use it to help you out. And then we're just simply subtracting exponent. My bigger exponent for my m is in the top, so I'm taking 5 minus 1, so that's m to the 4th. My bigger exponent for n is in the bottom, so we're taking 6 minus 3, so n to the 3rd in the bottom. That should have seemed like review to you for the most part. Because it really was. It's just a single term over a single term. What we're learning now is if you're given a rational expression, and let's go look at these for just a minute before we get started. We can't just start canceling terms to terms, because this is like a binomial or a trinomial. We have to factor them first to be able to cancel something out. So if we look at number 2, if you notice that already looks like it's in factored form, right? Because you have parentheses in the problem. And so once you do that, if you have exactly matching parentheses, like these x plus 4s, those can cancel out in that way. That's the only way, like, something that has a plus or minus sign can ever be reduced. So what would have happened before they got to this step is they factored out like a GCF. So you will always factor first. It says factor the numerator and factor the denominator, but number 2 was already like factored for you. We knew that because there's parentheses. Now we can reduce what's in front like we did here. 25 and 5 reduced down to just the whole number 5. Then x to the 3rd is the biggest x, and it's on top, so 3 minus 2 is 1. So it reduced to like a single term. It doesn't look like a fraction anymore, right? So there was nothing left in the denominator, so you don't really need to put that over 1 because that's understood. And then number 3, I don't generally give you ones that look like this, but just to kind of get you thinking a little bit, could you simplify what's inside those parentheses? You could. There's some other things that you could do maybe. But I want you to look at actually I want you to add an x. That's what I want you to do. So say x and put 3x plus 4. We're changing the problem. I don't like it. You're never going to see one like this. Okay, so it's kind of like it's factored for you. When you look at the top, is that binomial? Like, can you factor anything else out of that? No, you can't. But in the bottom, could we have factored something out of this? It's kind of like they pulled out an x, but maybe there was still something in common. Can 6 and 8 both be divided by 2? Yes. So what we would want to do is rewrite the top, because we didn't, this is a 3, not an x. It didn't need to, this one was factored right, basically. This one really, I just do it to draw attention to, like, sometimes we pull out the wrong GCF. We see that they can both still be divided by 2, so we would say we need to pull out a 2, but there was already an X there. And then divide by your 2's, figure out what goes back inside your parentheses. So 2 goes into 6 3 times, and 2 goes into 8 4 times. Now do those parentheses match? Yes. There's a couple ways you might have been able to go about that problem, but that's probably this. Now we're reducing. Right now it just looks like X over 2X. I'm going to clean it up because it looks really busy for me. Remember up here, there's an understood 1, and I am going to put it because what does it look like happens with the X's? They cancel, they zero out. So sometimes if we don't remember that a variable has an understood 1, we try to answer that like the answer's 2, which is different than 1/2. So it is in the bottom, so it has to stay in the bottom. And if it looks like nothing's at top, you have to put a 1 up top there. Okay. So one more that's already kind of factored for you. Are those parentheses matching exactly? X minus 4s over X minus 4s, yes. So they can cancel. And then we treat this front part just like we have the other front parts. 6 and 12 could be reduced to 1/2. Let's just think of it like a fraction for now. Let's go ahead and put the 1. Where's my bigger exponent for X? It's in the top. So when we subtract, we leave it in the top. So cleaning that answer up, we would only write X over 2. So it's not understood when there's nothing there, but when there's an X there, it is understood. I like to show both of those. So other problems, they're not factored for you. You have to go factor, which we know how to do. They don't tell you what to do. You need to always look for a GCF first. Is there a GCF in that top one? 2, and what else? Does it have variables? Yep, X squared. Yeah, so 2X squared. So you're going to factor out a 2X squared and put what's left over in the parentheses. If you need to see the division, you may need to, for the top part anyways, pull it over to the side. Okay, because you can't really write underneath that one since there's a denominator. So we deal with the top and the bottom separately. So right now we're just factoring out a GCF in the top. It's like you have 2 factoring problems, except for one's the numerator, the other's the denominator. So this would leave me with an X plus 2 when I simplify that after I factored out the GCF. What does the denominator have in common? X squareds. So there is room, and you wouldn't have to really rewrite that one. You could just write it underneath. So what am I left with in my parentheses? 3 minus 2 is X to the 1, 2, and just a 2. So you must factor first. I think the biggest mistake in doing this is trying to treat it like it's a single term, like we do up here in number 1, and just start canceling terms to terms, and you can't do that. You have to factor it, and then look to see if you have parentheses that match, and then cancel them out. Then like in this one, we could reduce it again. The X squared 0 out, so my answer is just what? Just 2. So being able to do this just helps you a little bit more with, remember we learned how to solve equations that had fractions in them? It just helps you be able to do problems like that that are a little more complex than what we've done. Helps you kind of understand some of those things a little bit more and then simplify it. Example 5, we're gonna factor this top and then the bottom separately. So just pay attention to the top for a minute. Am I using same or opposite signs when I factor that? Opposite. When I take 3 times 5, I get 15. Positive 3 minus 5 is their negative 2, right? So we split our x's apart, x and x, plug in plus 3 minus 5. I might go to those factors faster than you right now, and that's just because we're in class and lecture. But remember, you just go through those steps and you can find those. We'll go through those steps. So remember, you list what times what makes 15. Using opposite signs, you're trying to make the middle term by adding or subtracting. If it's opposite signs, you'd be subtracting, right? So that's how we got that negative 2. My denominator down here is x squared minus 9. Now that's a pattern, isn't it? Kind of dark now over my little pink highlighter, but that's a pattern, meaning I don't have a middle term anymore, do I? And are those perfect square numbers? Is 9 a perfect square? Yes. So remember, if we take 3 times 3, something times itself, it makes that number. And if we use the positive and the negative form, doesn't that zero out the middle term? That zeroes it out. So we split our x's apart and plug in plus 3 minus 3. So what cancels? What parentheses are exactly the same? The first one here and here. Just make sure your signs, make sure you don't accidentally cancel an x plus 3 to an x minus 3 because they're not alike, are they? Look similar, but they have different signs. So make sure they are exactly alike. Really, this is just kind of the surface of working with rational expressions. And really, in my opinion, all you really need to know how to do when you solve equations that have rational expressions in them, you need to just kind of understand this a little bit. So we're not going super deep in it. Multiplying rational expressions, you could almost think that this is one long line if you wanted. And just cancel tops to bottoms if you can. Any top to any bottom. Do I have matching r plus 2s? Do you guys see those? R plus 2s. So this one's already factored for you. Really, it looks like 6 over 20 now times 4r over 6. You didn't have to rewrite it, I just did. That should look a lot more like what you've done before, kind of, except it has a letter in it. You guys could either multiply or cross and reduce, or can't we do some cross reducing? Like 6 and 6 can both be divided by 6, right? So we can cross it out. How about 4 and 20? Can they reduce by 4, both of them? 4 goes into 4 one time, and 4 goes into 20 5 times. So I don't think I can reduce any more numbers, and that means I would just multiply across. 1 times 1r is a 1r. Over 5 times 1 is 5. But if you hate fractions, that's fine. You could have typed all of that into your calculator, just remembering that the r was in the numerator, right? You could have just typed, well, what is 6 over 20 times 4 over 6? It won't do the r for you. So it would have put a 1 over 5 in your calculator, but you knew you had an r there. And so we don't put the 1 because since the r's there, it's understood. It's all the understoods.
Why can't you cross out the whole 6r plus 2 if they're both the same?
Repeat that.
Like the 6r plus 2, why can't you cross like
You could have
out?
done that all right then because it's the same.
Okay.
Yeah, no, you can. I just pulled it apart like binomials and then single terms. You could, because then you would have just had 4r over 20 and you would have just reduced it. And that might have made it seem simpler, which it does. But what if these were not just sixes? You would have different numbers. That's how you would find out. Good question. So example 7, there are 4 different trinomials there, right? So you have to factor 4 different trinomials before you can ever cross anything out. You cannot, it never, ever, ever works and gets you down to the right thing by just canceling out some x squares and x's and stuff. Because this is a polynomial, and each of these polynomials represent like something specific. We have to factor it to see if they have some binomials that match that could then cancel. Okay, so we get to go through that factoring on all of them. Since this is a -6, I know I'm using opposite signs. Do my colors. And I'm using opposite signs to make a +1. If I take 2 times 3, that's 6. I have a -2 and a +3, that gives me a +1. Please set up your 2 parentheses. We're just factoring this top one right now, ignoring all those other 3's. And you'd have x minus 2, x plus 3. None of the factoring concepts change. In fact, hopefully it's just giving you a review of factoring, and then you just do something else in the end with it. I'm also using opposite signs with this one, but I'm trying to make a -1. So if I use the factors 4 and 3, if my 4 is negative and my 3 is positive, that would make the -1. So we would have x minus 4, x plus 3. And you have to factor first. Going to the next one, I'm using opposite signs again to make a +1. So 5 times 4 is 20. You have a +4 and then, a +5 and a -4. That would make your +1. I'm messing up my positive and negative words right now. This time I'm using same signs, because it's a +4 last term. So remember, that's the rules that were super important to learn the very first day we learned how to factor. If I take 2 times 2, that's 4, and if they're both negative, that would make your -4. So we have x minus 2, x minus 2. So now you have all these nice binomials that you can look to see if they have, if they're represented in the top and the bottom. So like, I usually just start with the top and work left to right. I have an x minus 2 here and 1 down here. An x plus 3 and an x plus 3. There's not an x plus 5 to cancel, but there is an x plus 4 here and an x plus 4. So notice when I have my x minus 2's, I can only cancel, if there's only 1 in the top, I can only cancel 1 in the bottom. This can't be canceled twice. You'd have to have 2 up here to cancel both of those. Each one can only cancel 1 alike on the top of the bottom. So I have this left over and this. So you just write x plus 5 over x minus 2, and it cannot be simplified any further. X plus 5 is like George, and x minus 2 is like Sally. So even though they both have a head, you don't cut their heads off, okay? So don't do it. It happens. People try to keep canceling that out. They're binomials. They just happen to both have x's, but they are 2 totally different things. Represent 2 different things. The only time we can cancel is if the entire thing crosses out. Like we did here, x minus 2 and x minus 2, the entire thing canceled. So those can be time consuming depending how fast you factor. But it's good practice in factoring. It's really important when you are solving equations that have rational expressions, so you can reduce it in the last step sometimes. And so that's really the only reason I'm continuing to cover it in this class. So that takes us on to this. We did do this already. I kind of wish we would have had this up there in that section, but I taught it, so it might seem familiar. You know, what you already know about fractions is that if they have like denominators, can't you add or subtract the tops? So in this one, 5 stays the same, and we would just take 2 plus 1 is 3. If you could reduce that, you would. Well, in the rational expression world, it might look like this. They both have x plus 3's as the denominator. And since we have 5 and 2 that are like terms, we can add them. We say that that is 7. It also could look like, let's say we have 2x over 2x plus 1 plus 1 over 2x plus 1. So that's looking a little bit busier, right? Do they have the same denominator? Yes, but my top, they are not like terms. So we would just say, I would write it like 2x plus 1. Are those the same things? So if we reduce it, it's not like it cancels and goes away. It's like it would reduce down to 1. So that's kind of why we learned what we did in the last section. So we can learn, what if you get down here and you're combining stuff, how would you reduce it if it's a polynomial? So pretty much though, the ones that we did in our section where we were solving equations that have rational expressions, if you remember, it was like, I don't know, 3 over x plus 2 equal 2 over x plus 2 plus 3 over x plus 2. And so I would tell you to like combine like terms over here because they have the same denominator, right? So 3 plus 2 was maybe 5. And then if you had a fraction equaling a fraction, do you remember what you would do to solve that? This is a nice review. So this would be like we would butterfly it. Yeah, we would take this times this equals this times this. And in my opinion, we have to do a lot of this in algebra, like solving equations that have like ugly fractions in them. And that's really all that chapter 8 helps us do that we use again. So that's why we're only going to talk about topic 8.1 and 8.2 now. The other stuff got really hairy, and I just didn't think it was beneficial. So there's no equal signs in this, is there? This was only to teach you how to combine like terms and then simplify. You're not solving for anything right now. So since these all have 2xy denominators, we just add or subtract the tops. And since these are like terms, we do that. So we're really just taking like 3 minus 5. Oh, that made it shiny, sorry. So it's like we're taking 3 minus 5 plus 9. So 3 minus 5 is -2 plus 9 is 7. And if you can reduce it, you would, but that one doesn't. So you would just be done. Again, this is not an equation. Remember, equations have equal signs in them when it's given. All we're doing is simplifying, combining like terms. Over here, I shouldn't put an equal sign so that doesn't confuse you, just an arrow. Over here, my denominator is 6b plus 8 for both of those fractions. So we just need to combine like terms. What's 2b and b? 3b. So don't be tempted to multiply because it has a plus sign in between it. So you're just combining like terms. And then I'm just taking 1 plus 3 is a +4. So over here, I said reduce. I'm looking to see if I can reduce this one, but remember, if you have more than one term, that means you must factor. The top can't factor, 3b plus 4. They don't have anything in common, but is there a GCF down here? 6 and 8 are both even numbers, so we know we can pull out a 2, couldn't we? So when we do that, we would divide by 2, so that would give me a 3b plus 4. So do we have something that matches? You may want to put a parentheses around that. That way it kind of helps you see it. When there's a binomial, I always do. Makes it look more alike. So do you see how the 3Bs plus 4 are the same? What would we put in top? Because I can't just go like this. 1. Doesn't look like anything's in the top. Looks like everything canceled. There's a 1 there. So this was adding, meaning, I mean, I know this one had a minus sign, so I guess it wasn't just adding. But mostly it just means if you have 2 of these, you have a plus sign between, you're really just combining like terms. Remember when we learned about subtracting polynomials? So this has a 2b plus 9 as its common denominator, but because there's a minus sign right here, it's kind of like saying I'm taking 7b plus 1 minus 5b plus 5. You would really need to put them in parentheses to think of it how when we learned how to subtract polynomials. They don't show it in a parentheses. So you may need to put it in there. I almost always put parentheses in it so I can look at it, look similar to stuff we've done in the past when it does have a parenthesis. If there's a minus sign there, what would we have to do? So like you're distributing, yes, which is changing signs. So good words, you probably were thinking change signs, distribute, it's all the same. Slash, yeah. So this was positive, it's now negative. This was positive, it's now negative. So you have to change the signs before you combine your like terms. So now you can ignore parentheses. 7b minus 5 is 2b. And 1 minus 5 is a negative 4. Okay, so these both have 2b's, but they have different constants, right? You can't do anything more. Don't be tempted to cut their heads off. Everybody needs a head. Okay, so keep that there. That's as far as you can go. So what I'm hoping that you're seeing from this is it is kind of bringing some concepts we've learned in the past all kind of together. And then you have to like factor to reduce it, which is why we learned how to factor too. So you should be brushing off some cobwebs in your head about combining like terms. It's been a little bit, but it'll never go away. So this one, again, because there's a minus sign right here, I generally, once you kind of remember, I generally just go change it right there. I don't have to rewrite it like I did that. I just wanted to show that to explain to you what you've seen before. And our denominator is still 3x plus 3. The 7x minus 5x is a 2x, and negative 2 and 4 make a positive 2. And we factor either or both of those by GCF. Always look for GCF, especially when you have 2 terms. Can they both be divided by 2? Since they're 2's? Yes. So if we divide by 2, sometimes I put it in there. I don't want to rewrite it. But that'd be like saying x plus 1. What could we divide by down here? 3. What? You want me to rewrite that so you can see that division?
Okay, is that division? Because I was
Yeah.
like, what is that?
What did she just write? Yeah, I know. Sometimes like what I do isn't the best thing to do for everyone else. So I said there was a GCF in common, and then I divided by 2. Just did it very
Okay,
slashy.
because I was like, is that y? I was like, there's no y.
No, there's
Okay.
not. It was just a sloppy division by 2. We said, what's in common here? 3. And I do have room to write it there, so I can. So x plus 1. So do you see how in the end they have like binomials, so those can cancel and you end up with no letters at all. Not always, but sometimes that happens. So I know that was very brief introduction of it. I didn't go real into depth. It is important content, and I will have you guys do a little bit of it on this next test. the biggest thing about this unit that you should pull from it is how to factor. Okay, that's more important than the A1 and A2 even, in my opinion. I think you guys did fine with where we used this without even going over this lecture first. So, cause we did it way back kind of in unit 1, just in a different way. So, so that actually is the last of this unit's lecture.